So today I'm working on the stainless steel here. Got two stainless steel metals I'm working with. This is a 304 stainless steel bar. I'm going to be cutting it into 2-inch sections with a chop saw and putting 2 holes in it. I'm going to drill one hole, clearance hole for this M8 bolt here, M8 by 125 that goes on this magnetic base, and that'll be used to mount offset with holders and post mounts and things like that. And so it's going to have one hole for the M8, and the other hole is going to be drilled for this 1/4-20 flush mount screw. And I've got a special drill bit here that cuts it, removes the material, and allows the bolt or the screw to be flush mounted on the bottom, so it won't interfere if we try to slide it around over here. And so this is a 82-degree bit specifically made for that kind of screw. And then also I've got this 410 stainless steel plate here. This is a 12-inch, 1/4-inch thick plate. I'm going to be drilling and tapping 1/4-20 threads in each of the corners to mount these rubber bumpers, so it can stand a little off of the floor that it's going to be sitting on. And then I'm also going to radius the edges of the steel plate and take the burrs off. It's a little rough. I want to sand it off a little bit. I'm going to be using a grinder, a sander, chop saw, and a drill press. I've got a 1/4-20 tap and the associated bit that's required. It's a 13/64 bit in this tap kit. And then also I'm working on this 3D printed mouse containment. This is like a tunnel that the mouse goes in. In this particular one, it's going to be bolted to one of these magnetic bases with this M8 bolt here. And this will also be allowed to slide around. And there's also magnets that will be embedded into this top, so this will be removable. There's a lot of assembly involved in just this 3D printed part. But today I'm working on the steel parts in my shop. I'm going to be using a lot of power tools and throwing a lot of sparks. So now I'm going to mark the spot for the rubber bumpers. And I want them just to be to the edge there. Got a spring-loaded punch here. And it puts a little indent in the metal. Let's see if you can see what I'm talking about here. One of the marks right there. Right there. So now I'm in here on the drill press. I've got my holes marked. I just want to drill and tap it. So I've got this little set here, the tap handle, and the taps, and each tap has its own drill with it, which makes it kind of convenient. But there's a chart I can show you that you can look up all this stuff. I've got one in my shop. You want to put the chuck in so it just grabs the smooth part of the drill. You don't want to put it in down where the sharp part is. And then you want to tighten 3 times, rotating around. It gives you the most even grip, even though it's not a big deal on this sort of thing here. Now what I want to do is make sure when I drill through, I'm not going to hit the table. And I see that I am right there, so I'm going to need to move my table over a little bit. Unlock it. And I'm going to move it up while I'm at it. And then make sure it's going through the middle. Tighten it down so it's stable. And now I just need to drill the 4 holes and tap them. Applying pressure, but not much. If I apply too much pressure, it overheats the bit. You can actually, you can feel the bit advance. So the next time I'm going to use that to hold it. This is kind of a big piece, so it's not a big problem. But now I can go ahead and center that on the hole. Put a little oil on it, and I'm just lightly holding it while I turn it on, and it can't rotate because it's touching the post here. So I went and got some Tap Magic here. It's extra insurance against damaging the tap. So now I'm just going to put these feet on. They go on the bottom, the top. I sanded the top smooth, but I don't really care that much about the bottom. Getting all the markings off and all that doesn't matter to me. It can always be sanded later if it becomes relevant. I'm just trying to get the prototype completed. There we go. So you can see the screws sit flush, so they won't be a problem. But I'm going to go ahead and sand that just in case. So here I'm cutting the 304 bar. I've got it clamped in this saw. This is an abrasive cutoff wheel. It's going to throw the sparks out that way. Even so, I'm going to be wearing a face shield and earplugs. so now that I've cut the first piece and it's cooled, I can use it to cut all the others. With a gauge, I just hold it up there flush, and then bring the saw in. And then tighten it. They're all kind of the same. Close enough. So the parts have a pretty sharp burr on them, and I'm going to get rid of that using the disc sander there. You always want to be on the downward slope. So over here on the drill press, I'm going to lay out where I want my holes. This is a 1-inch wide piece, and the post that goes here is a 1/2 inch, so I want to center that to support it fully. So I'm going to be 1/2 inch all around, so I'm just scribing it there. And then that gives me the, whatever, this intersection here is roughly there. So I'll put a indent on that one, and that's for this hole. This hole, I want it to be more to the side, and because it just has this head that's holding it down. So I'm going to go with 0.4 inches. And then also swing it out to 1/2 inch because I want it centered. And yeah, it's pretty approximate, I guess. So I'm going to punch that one in. Of course, I can make these any length and spacing I want. And I might find that I need to, but for now, this is what I'm going to go with. So this hole is going to be the 8mm clearance. That one's going to be the 1/4 I'm going to use this plastic and support the work in there and that way here. Here we go. So this one's the M8 clearance. And I'm going to need to lower my table. And I'm going to go ahead and drill all those at once so I don't have to keep changing the bit. So I'm just lowering the table until I can get the work under the bit. There we go, that's pretty good. Then I'll lock it down. Since I have a piece of plastic under there, I don't need to really worry about, I'm not going very much further. And so now I'm ready to drill. And the M8 one is that one. So I can see the bit wanting to go in there, in the indent that I made. And when I see it smoking, I know it's getting hot. job on that. Okay. So now I'm just going to switch out and do all the other ones with this bit. So you can see the bit's a little hot and it made the plastic stick to it there. That's pretty good. The bit is below the surface perfectly. Okay, so another thing I have to do is prepare this 3D plastic piece to be mounted on here. And basically I just have to remove all the parts that were excess in the printing and clean it up a little bit, get rid of the extra parts, the filling, the support pieces. There are some magnets that are going to go in these little holes here. And this print seems a little weak, so I'm going to increase the percentage of fill to make it stronger. Probably okay for the mouse, but now there's some holes I need to clear out. Here's one here. Not always easy to do. This is the main one I'm using for the mount. There are other holes, but I'm not really for a different application. I'm not going to need them right now. And so here's what I got built. Got this stainless steel plate with the rubber feet. This is the base of the behavior or the operant system. And this is a mouse tunnel, I guess you call it. You can put it wherever you want it, lock it with a magnet, and it's fixed. And this version is the convertible. It's going to have magnets embedded that made up, and you can actually put it on. It'll hold in place with a magnet, or if you need to pull it off or something, or you can pull it back to the next alignment of the magnets if you want, or just remove it. There's some feet that go in here that I need to put in, and then there's going to be more of these magnet mounts for the left and right that hold the head fix place. And these are some of the parts here that I made. These are stainless steel adapters. It holds, here's one here with the bolts in it. This 8mm bolt is going to go in the magnetic mount, and it's actually going to go in this way with that quarter 20 stud sticking up, and this is a below flush bolt here, so that can be mounted anywhere on the surface of that magnetic base, and it gets cinched down with this M8 by 125 screw. And so that's these are adapters that adapt the Thor post to a magnet base and allow you to put it anywhere you want. I've got a lot of other ones cut that I have to drill out, and I've got more of the feet, more of the hardware. That's like the kit of it, and this one's ready to go into the lab for some analysis.